Example 5, the exact same problem we just did a moment ago. This time it says using synthetic division. So let me describe a couple things about synthetic division before I actually demonstrate how to do it. First off, it only works if we're dividing by x plus or minus something. If it says divided by x minus 3, you can do it. Divided by x plus 5, you can do it. X minus 4, you can do it. X plus 1, you can do it. If it says 5x minus 7, it won't work. If it says divided by x squared plus 1, can't do it. It's got to be x all by itself plus or minus a number. Okay. If it is divided by x plus or minus a number, though, it's very easy to do, and it goes like this. First thing is the setup of the structure. I'm going to put a backwards capital L here. Stuff's going to go along here, so expect stuff to happen here. There's going to be stuff happening here, and then I'm going to have a bar here. So imagine notebook paper, this is on one line, this is on a second line, and then the bar here, that's the third line. So a total of 3 lines are going to be used on notebook paper when we're doing this. Whatever over here is affects what goes in here. What we're dividing by affects this. And what goes in here is the opposite of whatever this number is. So I look at this thing, and the question I'm asking myself is, what value of x makes that equal 0? What value of x makes x minus 3 equal 0? 3. The effect of that is just whatever this is, change the sign. So whatever number you see there, change its sign to its opposite. We're dividing by an x plus or minus something. If it's x plus, it's a negative. If it's x minus, it's a positive. Whatever that number is, change the sign. What is right here, that's supposed to be yellow. What is right here affects what goes right up in here. And what I'm going to put over here is just the numbers only of this in order, and if any power of x is missing, I must put a 0. So it's positive 5x cubed, so positive 5 goes there. This board is going to be, try again. All right, so positive 5x cubed, so put positive 5. The next number is negative 3x squared, x squared is accounted for. Next number is negative 18x, x the first is accounted for. Next number is negative 2, negative 2, x the 0 is accounted for. So x cubed, x squared, x the first constant. Every power of x is accounted for, so no zeros showed up. If this, for example, if this weren't there, if that just said 5x cubed minus 18x, this would now be a 0 here. If something's missing, you must put a 0 to account for it. If you don't put the 0, you'll get the wrong answer. All right. Notice I didn't write any x's. I simply wrote the numbers. Whatever makes this equal 0 goes here, and whatever the signs and numbers are here go there. 5's positive, 3's negative, 18's negative, 2's negative. The final step of the setup is whatever this number is, you put a little arrow there and put it underneath the bar. Okay. That's how you set up synthetic division. Everything comes from somewhere. This comes from there, these come from here, and whatever this number is gets below the bar. All right? Once we set it up, now we're ready to get the answer. Okay, here's how we're going to get each answer. We get an answer going up here, we get a number here by multiplying these together. So I'm going to take whatever this is, and I'm going to multiply it by that number to get this number. Signs matter. Positive 3 times positive 5 makes positive 15. To get the number that goes down here, I'm going to add the numbers in this column. Negative 3, add algebraically. Negative 3 plus 15, the signs are different, so I subtract. 15 is bigger than 3, so it's positive. All right? So I need to get my next number over here. I'm going to multiply 3 times 12. Again, I'm always multiplying this times the next number over to get the next number up. Positive 3 times positive 12 makes positive 36. I'm going to add algebraically down. Negative 18 plus 36, signs are different. I get 18, I subtract, 36 is bigger, so it's positive. That's how I get that number there. And finally, this number here, I'm going to multiply 3 times 18. Positive 3 times positive 18 makes positive 54. And then I'm going to add, algebraically, negative 2 plus 54. Signs are different, so subtract. 54 is bigger, so it's positive. All right? So that's the technique. Couple disclaimers. When I'm doing synthetic division, I don't draw all these arrows, I don't draw all these boxes. I simply have a number, I multiply up, I add down, multiply up, add down, multiply up, add down. Each time I multiply this number times this to get the next number up, this number times this to get the next number up. So it's always refer back to this every time. Whatever this is on the bottom times this gets the next number up. Once you get the next number up, you get the next number down by adding algebraically. Multiply to get up, add to get down. Multiply to get up, add to get down. Multiply to get up, add to get down. Very systematic, very quick. And it really gets good practice at all these sign rules we've been dealing with here recently that some of you guys have been struggling with. So really focus on the signs. I don't usually write positive signs on these either usually. I don't usually do that, but just to reinforce what's been struggles for you guys, I'm going to do that. So, is everybody comfortable with all the numbers came from? All right, I'm just going to take this out of the way, maybe. Just so it's out of the way, because again, I don't usually have it all there. So, interpretation of the answer, because the answer is this. And you'll notice this does not say what that says. They put them side by side, they don't say the same thing, right? What's the same? The 5 and the 12 and the 18 and the 52, right? All these numbers we're getting, that's what we're getting out of the synthetic division. We took all the x's out of the picture, figuring out all the numbers are. Now we've got to put all the x's back in. The way we put the x's back in is this is always the remainder. If you go from right to left, the last number is the remainder. This is the constant. No x at all. This is x to the first. This is x to the second. Just works its way like that. The other way of doing that is look at what the power of this is. This power is 3. We're dividing by x to the first, so the power drops from 3 to 2. Second power, first power, constant, remainder. Either go left to right in that manner or start remainder, constant, x squared, whichever way you want to go. So I'm going to write this in that manner. So when I write my final answer, I'm going to write 5x squared plus 12x plus 18 plus 52 over x minus 3. The remainder goes over the divisor. The rest of the stuff has x squared x and a constant. Notice everything's positive, positive 12, positive 18, positive 52. A lot of times people start this process with this. They don't write the positive signs. They'll write their answer like this. 5x squared gap, 12x gap, 18 gap, 52 over x minus 3 gap. I know what you mean, but that's not the right answer. All right? So make sure that once the first object's been written down, positive or negative, positive doesn't have to have a sign, negative does have to have a sign. After that, everything has to have a sign between it based on the sign of the numbers. So this is positive, put a plus, that's positive, put a plus, that's positive, put a plus. Okay. We get the same answer both ways. Again, this way that's the right answer, this way that's the right answer, because that's the answer to the problem. It's just a different technique to do it. And again, it works every single time you're dividing by x plus or minus a number. Okay, I'd recommend getting good at it because it's quick. Okay, it didn't seem quick because I talked all about probably 10 minutes about it, but you do it by hand and you know what you're doing, you're looking at maybe a minute or so to do these problems instead of 4 or 5 minutes. You'll prefer this.